So in a problem like this, we're going to be looking at applying the laws of exponents, but then also looking at involving some negative exponents and some rational or fractional exponents. So what's interesting about problems like this is that there are many places you could start. So to start off, you definitely could find the reciprocal of y, or you could multiply these together. So it's up to you where you start. In this case, I'm going to multiply all of this bracket by all of this bracket. So this ends up becoming x cubed times x squared. X cubed times x squared. And I'm going to write out the step here just to show you. And because there's no addition or subtraction, we're not doing our expansion like we would have in chapter 3. We're just also going to be multiplying y squared by y to the negative 4. So really, this all just becomes multiplied together. And then when we see that there are similar bases like x and x, y and y, and they are being multiplied together, we're permitted to add the exponents. So this will really become x, 3 plus 2, and this will become y, 2 plus negative 4. So we end up with x to the power of 5, and we end up with y to the power of negative 2. But in a simplified expression with any sort of exponent, we are not allowed to have a negative in the final solution. So we will need to find the reciprocal of y, which is just 1 over y. But because we have applied that negative, that squared remains there. And at this point, that is all we can do. We cannot simplify any further. So this would be our final expression. That is our solution. You could absolutely have started by rewriting the second expression here as x squared divided by y over 4, and then completed it that way as well. So in this one, we're going to be looking at simplifying the numbers together, simplifying the a's together, and then also simplifying the b's together. So I'm just looking for a different color here, b's. And this involves the quotient principle. So 10 divided by 2, that's 5. We can do that. But then we have a to the 5 divided by a to the 2. I'm just going to separate this just to show you. And then we have b to the 3 divided by b to the negative 2. So when we are dividing values that have the same base, like a and b, we actually are subtracting the exponents. So again, that 5 remains, and this is going to become a to the 5 minus 2. And this will become b to the 3 minus negative 2. So we will end up with 5, a to the 3, b to the 5. And at this point, that is as simplified as it can get. So this would be our final solution. And once again, you absolutely could have started by finding the reciprocal of this, which would end up putting b up here as b squared. And then you would have b cubed times b squared, which would still give you b to the 5. So many entry points for these problems and many ways to get to the same solution. We'll do 2 more here because these ones involve some fractional exponents. So we're going to try doing a d, and we'll also try doing b. So b in this case, again, we can multiply together the values with the same bases. So we'll end up with x 3/2 times x 1/2 times y 2 times y to the negative 1. And again, once there are the same bases, we are allowed to add the exponents when they're being multiplied. So we'll end up with x 3/2 plus 1/2 and y2 plus negative 1. So we'll end up with x And in this case, 3/2 plus 1/2 is 4/2. And y is 2 plus -1 is just to the power of 1, which we don't even need to include that 1 there. I'll put it there just to show you in that step. And then if we can simplify further, well, 4/2 is just 2, x to the power 2, and y. So this would be our final solution. And then D is a very complex problem. So I'm going to do everything inside the radical first and simplify, and then apply this 1/2. So again, we're going to look at numbers, simplifying with numbers. So 100 divided by 25. We'll look at A divided by A to the 5. And then we'll look at nothing divided by B to the 1/2. So 100 divided by 25, that's 4. And then we have A divided by A to the 5. And then I'm just going to rewrite B to the -1/2. Well, B to the -1/2, to eliminate that negative, I could actually put B in the numerator to the 1/2. I'll just keep it over 1 there. And this is all raised to the 1/2. So I'm going to divide these out. So we're going to end up with A to the 1 minus A to the 5. And then we still have B to the 1/2 here, all raised to the 1/2. So I'm going to simplify. It'll be 4A to the -4, B to the 1/2. And before I apply this 1/2, I'm just going to simplify one last time. I cannot have a simplified solution with a negative. So this will actually become B to the 1/2, and the reciprocal of A to the -4 is 1 over A to the 4 to the 1/2. So now at this point, what we're doing is this 1/2 means we're taking the square root of 4B to the 1/2 A to the 4. So we're just going to be applying this 1/2 to each of the values. So instead of writing it as the square root, we could also just rewrite this, as 4 to the 1/2, B to the 1/2 times 1/2, and A to the 4 times 1/2. So we're multiplying the products by each of the products, but we can't remember to also apply it to that 4. So 1/2 of 4, that's the square root of 4, which is 2. 1/2 times 1/2 is 1/4. And 4 times 1/2 is 2. So this would be our final simplified solution.